Hello friends, earlier we have gone for basic understanding of the problems of maxima and minima. Now we will solve certain particular problems which are very important and which will enhance your complete understanding of maxima and minima. See here in the first problem, show that semi-vertical angle of cone of maximum volume and of given slant height is tan inverse root 2. Firstly, we will draw the figure how to interpret the problem. See, it is a cone. Semi-vertical angle we are concerned about, that theta. Okay, what is given? Given thing is the slant height. L is constant and the variables are R and H. The first thing we have to write the term whose maxima or minima we have to deal with. We have to find the maximum volume of cone. So first instance we will write the formula of that is 1 by 3 pi r square h. As we have seen that we have to get rid of one extra variable, or we have to introduce the variable which we want to get. I am just removing one variable. What relation I am getting from this geometrical figure is L square is equal to R square plus H square. Okay, so if I get rid of R square, I will write this in the terms of H only. That will be L square minus H square into H. So we have just step number 1, writing the term whose maxima or minima to be found out. Step number 2, get rid of the extra variable. Step 2 is over. The third step is we have to differentiate with respect to the leftover variable. Now just little bit of simplification is giving us 1 by 3 pi L square h minus h cube. Okay, now step number 3, we have to differentiate with respect to h here, the leftover variable. 1 by 3 pi constant outside, it is L square, h is 1 minus 3h square. Okay, and step number 3 is that we differentiate and put it equal to 0 to get the value of the variable. So if I put it equal to 0, I will get L square is equal to 3h square, and L square, because we have to deal with tan theta. Tan theta involve R and H. See here, tan theta is perpendicular by base. So tan theta is R by H. So we are concerned about R and H only, because we have to get result that only. So we can just write it as R square plus H square is equal to 3H square. So we get H square is equal to 2H square is equal to R square. So we can just write R is equal to root 2H. So R by H is equal to root 2, and we see from the figure R by H perpendicular by base is tan theta. This is the semi-vertical angle. Complete is vertical, semi means half of the vertical. So this tan theta is coming out to be root 2, and you know that theta will come out to be tan inverse root 2. So the thing is proved. One thing we have to do, we have to double differentiate this to prove that at this value of theta or this value of R and H, the thing is maximum. So what we will do, we will just double differentiate this d square v by dh square. From here, double differentiate from here. Don't be confused. You just double differentiate and see what it is coming out to be. 1 by 3 pi constant L square is 0, and that is minus 6h. So ultimately it is coming out to be negative, you see here. And if double derivative is negative, then the thing means V is maximum. Where? It is maximum here at this value of this thing. So the volume will be maximum when theta is tan inverse root 2. See in the next question, A open box of maximum possible volume from a square piece of tin of side A is to be made by cutting equal squares out of the corners and folding them to form the box. Okay, what is the geometrical interpretation of the thing? A square sheet is there. We are cutting square portions from all the corners, all the four corners, and just removing the cut portion and folding up the flaps, we will get an open box. We are concerned with the volume of that open box. We have to find the side of the square to be cut off. It's x everywhere. See, x. See, now after cutting off the square from the four corners, a box is formed. What will be the volume of the box? That is length into breadth into height. Why? Because that is going to be a cuboid. Okay, so the volume is length. What is the length of the box? Actual length was A, you know, it's given in the question. So we are cutting x here and x here. So the new length is coming out to be A minus 2x. Same way, new breadth is coming out to be A minus 2x. And what is the height? The portion which is coming up is just x. So we have done step number 1 and 2. What is that? Writing the thing whose maxima or minima to dealt with. We wrote it. Just getting rid of the extra variable, we did it by means of the geometrical figure, and just 2 steps over. Now what we have to do, we have to differentiate and put it equal to 0. On simplifying, it is coming out to be a square minus 4x plus 4x square into x. I just recommended go for a little bit of simplification. The things will be easier for you. Why? This is a minus 2x whole square, so a square minus 2ab 2ax plus b square, that is 4x square, and into x. So it is coming out to be a square x minus 4ax square plus 4x cube. Now very easy to differentiate. Differentiate with respect to x. The variable left over is only x here. We are getting a square. What is here? 8ax, because x square is giving you 2x. Okay, and this is 12x square, because x cube is 3x square. We put it equal to 0. We will get 12x square minus 8ax plus a square is equal to 0. So on factorizing this, it is coming out to be 12x square minus 6ax minus 2ax plus a square is going to be 0. So on taking 6x common here, this is x minus 6x we have taken common. This is 2x. This is 2x minus a minus, if I take here common a, this is 2x minus a. So x is ultimately coming out to be a by 6 or a by 2. A by 2 is not possible. Why? You just see, if we just write here a by 2 for x, the volume is going to be 0. That complete portion has been cut. So we have to pick up this value. Moreover, if we double differentiate this and put the two values, if we double differentiate d square v by dx square, just double differentiate, this is coming out to be a square 0, this is minus 8a, and this is 24x. Yes, so you put the value of a here, you at a x is equal to a by 6, at x is equal to a by 6, you just put x is equal to a by 6. This will be negative. What does this mean? This means that volume is maximum when the side cutoff of each corner from each corner is a by 6. So we have proved the thing. See, in question number 3, window is in the form of a rectangle surmounted by a semicircle. Just draw the figure. Shape of the window is like this. Rectangular portion and then a semicircular portion. Perimeter is 30 meter. Find the dimensions so that greatest possible amount of light to be entered. Just interpret the figure. If this we are taking as x, this is y, this is y, this diameter is going to be x. See, firstly we have to write the area of the combined figure. So, because we have to find the maximum value of the area, so maximum amount of light to be entered. So, A is coming out to be area of that rectangular, that is x into y, plus area of the semicircular portion. What is that? 1 by 2 pi r square. R square. What is r? R is here x by 2. See from the figure. Because diameter is x, so radius is x by 2. That means x by 2 square. So the first step is over. Always write the first step whose maxima or minima to be dealt with. So I wrote it. Now I have to get rid of extra variable. How can I get? With the help of the given figure or the given conditions. See here, the total perimeter is given. The perimeter of the window is x plus 2y plus pi r, because complete circumference is 2 pi r and that is semicircular, half portion is there. So this is pi r. R is what? X by 2. Is equal to given 30. See here, we are not involving this thing because the perimeter is like this, starting from here, here, coming here. So this is not to be included in rectangular portion. So we will just get the value of one thing. If I get the value of y, it is coming out to be 30 minus x minus pi x by 2 divided by 2. So I got the value of y, so that I can put it here, just making in the terms of single variable. Little bit of simplification will give us 30, 60 minus 2x minus pi x by 4. So y we got, we will put it here. So it is coming out to be x into y means 60 minus 2x minus pi x by 4 plus half pi x square by 4. So we got it in the terms of single variable x only. Little bit of simplification I am doing so that differentiation will be easier. So it is coming out to be, if I take 1 by 4 common throughout, I am just left with 60x minus 2x square minus pi x square plus 1 by 2 pi x square, because I have taken 1 by 4 common everywhere. Now you just differentiate dA by dx. So it is coming out to be 1 by 4. This is just 60 minus 4x minus 2 pi x plus 1 by 2 pi into 2x. That we have to put equal to 0. So we will just combine the x things here. It is coming out to be 60 is equal to 4x. This is minus 2 pi x and this is plus pi x. So minus pi x, so plus pi x it will come out to be, and we will get the value of x here. X is coming out to be 60 by 4 plus pi. So we got the value of x and we can get the value of y very easily by just putting the value of x here. We got the dimensions of the window, x and y, because it is dimensions are being dealt with x and y only. Radius is also in the terms of x, so we'll get all the dimensions. One thing we have to prove, whether at this value of x the thing is maximum or not. So what we have to do, we have to double differentiate this. We will just double differentiate this d square a by dx square. We have done so many times in the previous question. You just double differentiate, put value of this x on the double differentiation thing, and this will come out to be negative. You will see, if this is negative, then a is maximum. Where it is maximum? At value of x this, and value of y this, on putting the value of x here. So at this value of x and y, area will be maximum. Now see question number 4. A wire of length 28 meter is to be cut into two pieces. One is made a square and other a circle. What should be the length of the two pieces so that combined area is minimum? So first thing, we will write the combined area of circle and square. What is that? It is pi r square plus a square. Very simple. Now we have to convert it into single variable. So we will get help of the given thing. Given thing is that total length is 28. What means the total length? Total length of the square piece and the total length of the circle piece. The total length of the square piece is very much obvious, 4a, and that of the circular piece is 2 pi r. That complete thing is given 28. So we will get value of one of the variables. Suppose I am getting the value of a. A is 28 minus 2 pi r by 4. So I will get the equation in the term of single variable, that is r only. If I just write the value of a, this is pi r square plus a square means 28 minus 2 pi r by 4 square. So up to 2 steps we have done. We have to differentiate now, and on differentiation it is coming out to be dA by dr. What is that? Pi into 2r plus, just take help of the chain rule and differentiate it carefully. Something is square, so 2 into that thing is 28 minus 2 pi r by 4 into 28 by 4 is 0 minus 2 pi by 4, and that we have to put equal to 0. So what we are getting, see here, 2 pi r is equal to, coming out to be 2 into 28 minus 2 pi r by 4 into 2 pi by 4. Just I separated the things. This negative thing I have taken to that side, and now simplification is giving us this 2 pi is getting cancelled. So what it is coming out to be, if we just cancel here, this is 2, so 8 is there. So what is that? 8r is equal to 28 minus 2 pi r. So what is r? R is going to be 28 divided by 8 plus 2 pi. What I did here, I just brought r to this side, took r common. If I take 2 common, it is going to be 14 divided by 4 plus pi. So I got the value of the radius of the circle. So the length of the piece which is circular is not that. The length of the piece, circular piece is, length of circular piece is 2 pi r. So length of circular piece will be 2 pi, and r we got 14 by 4 plus pi. And the length of the square piece will be 4a. What is that? 4a. We will get the value of a from here, and we can just get the value of, or you can just write 4a is equal to 28 minus 2 pi r. Whatever value you got it, you will get. This is the length of the square piece, and this is the length of the circular piece. This is not actually the length of the circular piece. But one thing we have to do once again, we have to differentiate, double differentiate this. D square a by dr square, and at this particular value we have to check what it is coming out to be. You will see that is at this particular value, that means at r is equal to 14 by 4 plus pi will come out to be positive. You will see, you just differentiate, double differentiate this thing, put it r is equal to this thing, the thing will be positive. Once d square a by dr square is positive, that means a is minimum when r is this thing. So we got the minimum value of the pieces on putting the value of r like this. Hope you are understanding how to tackle the particular problems of maxima and minima. Thank you.
For useful videos, subscribe to my channel Santosh Pembi on YouTube or log on to my website www.mathsonphone.com. Thank you.